Okay, great. All right. Thanks for watching. Please subscribe to my channel. Now, in this video, we'll be exploring a very important tool in differentiation, and that is the chain rule. Good. So suppose we have a function, all right, written in terms of u, and then u is in turn written in terms of x. Then we can differentiate that function just by applying the quotient rule. Good. And this is what it states, that dy dx will be dy du times du dx. Anyway, we'll get back to this, right? First of all, let's differentiate the following functions. First, we have 2x plus 3 all raised to the power 2. Well, to differentiate that first function, we can just go ahead and expand that bracket, all right, using just the binomial expansion theorem. And then when we're done expanding, we can apply the sum rule and then the power rule and differentiate each of the terms. So let's just go ahead and differentiate that and see real quick. So we have the function to be 2x plus 3, then raised to the power 2, right? Good. Now the derivative of this function, let's call this function y, right? So the dy dx, since this is the function written in terms of x, will be, well, we go ahead and expand this and then differentiate that, all right? So let's see, maybe before we do this, let's expand that function. So that tells us that y is, when you expand this, you're going to have 4x squared plus 12x plus 9. Good. That is just by applying the binomial theorem on this. We're going to have 2x all squared plus 2 times 2x times 3, all right? And then plus 3 squared. Good. And from there, we're going to differentiate that function. So we find dy dx to be, well, we differentiate the first term, the second term, and the third term, all right? Just by using the sum rule and the power rule. Good. So when we differentiate this, we're going to bring this power to the front. So we're going to have 4 here, and then bring the 2 to the front, multiply with the 2, and then put down the x and subtract 1 from that 2. So when we subtract 1 from this 2, we're going to have just 1 as a power. And then we add it with, well, the derivative of 12x is just 12, all right? Good. And then plus the derivative of 9, which is just the constant, is going to be 0. So all in all, we enter with 8x plus 12. And this right here is the derivative of that function, given just by expanding, all right? So we expand and simplify a little bit, and that's what we get. And you're happy, right? Good. Okay, let's go ahead and look at the second one. We have x minus 5 all raised to the power 101. Are you going to expand this? No, definitely not, all right? Okay, so this was just to power 2, and we were having 3 terms after expansion. This that is to power 101, we are expected to have 102 terms after expansion, which we've got no such time, all right? This is where the chain rule will come in, a very important tool. Good. So here we can look at this as y equal to, just put down the main function, x minus 5 raised to the power 101, all right? Good. So this rule tells us, if you have a function y, which is written as a function of u, and u is in turn written as a function of x, all right? Then we can differentiate that just by using the chain rule. Now this is what I'm going to do. I'm going to first of all start off with a substitution, all right? I need to bring in u, this variable u. Now, since this is y written in terms of x, and it is x minus 5 raised to the power 101, I'm going to figure out the u as the inside function, all right? Just the inside, okay? I'm going to replace the inside here with u. That means I'm going to say let u be x minus 5, right? That is just the inside. Good. Replacing the inside with u, we're going to have, we can now rewrite the function y to be, so in place of x minus 5, I'm going to put u, and I raise that to power 101, all right? Good. And then this rule tells us to find dy dx, we need to find dy du and multiply it with du dx. So dy dx will need 2 components to be multiplied together, dy du. So given that y is u to the power 101, we can easily get dy du from here, right? Since it is written in terms of u, just by using the power rule. So we're going to have dy dx to be So since this is just like considering x to the power n, right? You bring the whole 101 to the front, just bringing it to the front. Then you put down the u, which is the variable in this case, and then you subtract 1 from 101, all right? Subtract 1 from it. Good. Okay, so when you do that, you're going to enter with 101, then u to power 100. That is just it, all right? So this right here is the dy du. This is dy du. Okay, good. And then the second component we need is, let me erase this part. The second one we need is du dx, all right? And to get the derivative of u with respect to x, we will need to make use of this equation because this is a u, all right, written in terms of x. So from there we can simply get du dx from there. So I'm going to write it down as du dx to be, well, here we have x minus 5. So we're just going to apply the difference rule, all right? So the derivative of x with respect to x is just 1. So you put down the 1, and then minus the derivative of 5 with respect to x. Well, since this is just a constant, the derivative there will be 0. So all in all, we enter with just 1 to be du dx. Good. And then finally, we can now use this chain rule equation, all right? Which tells us that the dy dx will now become dy du. So dy du is given to be 101 u to the power 100. So just put that down. And then we now multiply it with, so it's just a product with du dx. Du dx is just 1, right? So now multiply that with 1. Well, when we multiply this together, we're going to enter with 101, then u raised to the power 100, right? But here, we need to find the derivative of y with respect to x. That is, differentiate the function y with respect to the x variable. So y is a function of x. The reason is this last function, we need to write it in terms of x, all right? In terms of the independent variable of the function. So that means we are going to have to replace u with the expression that contains x. What is u? U is x minus 5. So I'm going to replace u here with just x minus 5, all right? So we're going to put down 101. Then in place of u, we put down x minus 5. Then we raise it to power 100. Good. And this right here is the derivative of that function, right? Which we couldn't do it just by expansion. But with the chain rule, we can break it down. Okay, great. All right. Thanks for watching. Please subscribe to my channel.